When we first learned of the project, the first question we asked ourselves was, where do we start? What type of projectile launcher do we want to use? We came up with a couple of ideas in order to start. The first was a tennis ball launcher that we had found on the internet. Another was to make a big sort of slingshot. We also thought about making a crossbow. We had to ask ourselves, though, which one would be more effective when we try to use it. Because of this, we came up with some variables, some things that we thought would be important. We had to think of which one would be lightweight. Also, we needed something that would be able to fire a lot of tennis balls very quickly in a short amount of time. Had to be easy to use, easy to move around. Had to, that way we could have some sort of adaptability if something went wrong or if we needed to change anything. We had to have control over it. Most importantly, it had to be accurate. We had to be able to hit these targets and get very close at least. So, in order to do this, we started with a model after we decided that the crossbow would be the best way to go, and it would also be fun to make. So we made a model out of blocks that we found in Mr. Whippler's classroom, and then from there we came up with our first operational model. But we hit some road bumps and we had to change up our idea, which led to the model that we used on the actual test date. So this is our crossbow, and what we did was we used PVC pipes in order to create a system that would guide the ball down. Using duct tape, a piece of wood, and surgical tubing, we were able to create force through the tension in the surgical tubing in order to fire the ball out, which will come out through here, and depending on how much force we use, which we determined by marking off on the PVC pipes with pieces of tape, we were able to get close to the different targets. We also needed to make sure that we were able to identify the type of variables that we would be dealing with our projectile launcher. We already knew that we would have set distances that we needed to hit, but in order to make this easier for ourselves, we also wanted to have a set angle, something that we already knew, so it would make calculations that much easier to make. And also, in order to help us with our group, since there are only two of us and it would make launching something bigger very hard, we came up with the idea of having a base for our projectile launcher. This would give us a fixed angle and also allow one person to launch the tennis ball and the other to retrieve, making our system as effective as possible. And this only left us with really one other thing to decide, one true variable. That was the force needed to actually launch the tennis ball. With this, we we went through multiple test runs of what length the or how far back the surgical tubing had to be pulled on our crossbow in order for it to launch the proper distances. We had to overcome a few variables or obstacles when launching. One of them is gravity. Gravity wants to pull this tennis ball towards the earth because Earth's gravitational force is much greater than the tennis ball's due to its mass being so much larger. This means you need more force and more of an angle in order to get to the target. You also need to put extra force behind the ball because the ball will slow down during its flight due to the friction it endures. This means that in order to reach the target, due to the friction, you need to put extra force for the ball to get to the target. In a frictionless world where everything is perfect, you would need less because the ball wouldn't slow down during the flight. It would only drop due to gravity.